Today we're going to be using our special triangles that we learned about in the last lesson to try and solve some questions using the patterns that we saw and some, well, hopefully some shortcuts that we can look at. The first question says an iPod, a square iPod screen, has a length of about 2 inches, has a side length of about 2 inches. What is the diagonal of the screen? So I drew myself a little square here. I know that it's 2 inches on either side, and this length is what we're looking for. So there's two ways to do this. One, I could use the fact that they have two sides here, and I can use my Pythagorean theorem and do a squared plus b squared equals c squared, the full length here. Or I can use my shortcut. I know that whatever this is, this side length, I multiply that times the square root of 2 if it's a square, and I will get the full length on the inside. Let me explain that once really quick here. Whatever this length is, hold on, this length here, we multiply that times the square root of 2. So in this case, 2 is the length of this side, times the square root of 2 will give me the length of that diagonal. So that's all I need to do. So I can punch that into a calculator, or I can know that the square root of 2 is something, I think it's about like 1.4. Anyway, if you multiply that 2 times the square root of 2, you'll find that that length is approximately 2.8 inches. All right, not bad. So that shortcut saved us having to use the Pythagorean theorem. So that's kind of nice. Let's look at the next question. And this one we're going to be solving with a British accent. I'm not very good at the British accents, but we'll try it out anyway. If a triangle has a length of 15, 30, and 15 times the square root of 3, what type of triangle is it? Well, from yesterday we saw that certain types of triangles had one side, the shortest side, doubled would give us the longest side. And when we multiply that shortest side times the square root of 3, it will give us the length of the other side. So let's go ahead and try and recall what type of triangle that was. Let's draw it up here. We had a short side that was 15. The hypotenuse of the triangle was 30. And if we multiply 15 times the square root of 3, we get the third side. If you recall, this type of triangle was a 30-degree, 60-degree, and 90-degree triangle. So that's the solution to this question. We need to remember those patterns, and when we see 3 lengths, we should be able to determine whether it's a 30, 60, 90, an isosceles, a scalene, or a 45, 45, 90 triangle. Now we're going to solve one using a Scottish accent. We're going to create our own 45, 45, and 90-degree triangle and label the lengths of each side. For this, we just need to pick a length for these two sides, and then we need to use this one. We need to pick that shortcut we saw earlier. I'm going to try and make life easy. I'm going to pick the length of 1. So if I say that this is the length of 1, and this here is also the length of 1, because with a 45, 45, 90 triangle, you know that this side is equal to the length of this side. Now this side here, all we need to do is we say it is the length of the other sides times the square root of 2. So that will mean that 1 times the square root of 2 simply gives us the square root of 2. So now we've created ourselves a 45, 45, 90 triangle with the lengths of 1, 1, and the square root of 2. Any number you put in here would be fine, as long as you multiply it times the square root of 2. For our next question, we're going to be looking at a 30, 60, 90 triangle, and it's a triangle-shaped flag. It hangs down 23 feet, and they're going to ask us, they are asking us, what the length of the longest side is. So let's take a look here at this triangle. It's like a flag here. It hangs down 23 feet. We know it's a 30, 60, 90 triangle. And so what we're trying to do is find out what is the length of this longest side. Well, what we know about these triangles is that whatever this here length is, I'll call it x, this is 2 times x, and this is x times the square root of 3. All right? That gives us these lengths. So if I'm trying to solve, I'm given this length, and I'm trying to do this in reverse to get that, watch what I'm going to have to do. If I were given this length, I would have to multiply it times 1/3, or the square root of 3, to get 23. Because I'm given this length, I'm going to have to divide it by the square root of 3 to find this value of x. Okay, so 23 divided by the square root of 3 will give me that length. Does that make sense? X times the square root of 3 is 23. So if I'm trying to find the value of x, I need to divide by 23. Here, I can write that out in math language over here. I say x times the square root of 3 is equal to 23. So to solve for the value of x, I need to divide both sides by the square root of 3. They'll cancel out, and x is equal to 23 divided by the square root of 3. Now we're going to be approximate here and just say 23 divided by the square root of 3, and I'll just take, let's see here, a very approximate answer is 13.228. That's pretty approximate, but it'll work for what we're doing. Now, x is equal to 13.28. That means that's the length of this side. But we are asked to find the length of the longest side, and that's 2 times this amount. So what we can do is we can multiply that 13.28 times 2, or if you save that number with all of the decimals in your calculator, like I did, you can multiply the full number times 2, and what you'll end up with is 26.56 approximately is the length of the longest side. All right, so this question is probably the most complicated type of question that you'll see, but I wanted to go over it because we are going backwards, but using the same patterns that we saw earlier. So I hope this mini lesson's been helpful for you and fun. Have a wonderful day.